What is the radius, r, of the circle and the area of ABCD? Let angle AD, C equals alpha. Because ABCD is uniform trapezium, extend line D, A to H. It implies that angle AD, C equals angle H, A, B, which equals to alpha. It is because corresponding angles are equal. Thus, angle DA, B equals to 180 degrees minus alpha. It is because the sum of angle in a straight line equal to 180 degrees. Locate the center O and label point E. Join line E, O, which is a perpendicular line. Thus, line E, O equals radius, r, of the circle. It implies that angle EAO equals to half angle DA, B, which equals to 90 degrees minus half of angle alpha. From right triangle EOA. Half of r equals sine 90 degrees minus half of alpha. By trigonometric identity. Sine 90 degrees minus half of alpha equals cosine half of alpha. Substitute in equation above. We have that half of r equals to cosine half of alpha. We call it equation 1. Label point F and join F, O, which equals to R. But angle D equals angle C, which equals alpha, and alpha equals the sum of half of alpha and half of alpha. It because base angles of regular trapezium are equal. From triangle FOC. 1/3 of r equals sine half of alpha. We call it equation 2. Thus, we obtain two equations. It implies that half of r equals cosine of half of alpha. It is equation 1, and 1/3 of r equals sine half of alpha. This is equation 2. Thus, square equation 1 and equation 2. We obtain that the square of r divided by 4 equals the square of cosine half of alpha, and the square of r divided by 9 equals the square of sine half of alpha. Add the two results. It implies that the sum of the square of r divided by 4 and the square of r divided by 9 equals the sum of the square of cosine half of alpha and the square of sine of half of alpha. By trigonometric identity, the sum of the square of cosine half of alpha and the square of sine of half of alpha equals to 1. Substitute in the above equation. Thus, we obtain that the sum of the square of r divided by 4 and the square of r divided by 9 equals 1. It implies that simplify, and we have that The sum of 9 times the square of r and 4 times the square of r all divided by 36 equals 1. Cross multiply. Thus, the sum of 9 times the square of r and 4 times the square of r equals 36. Thus, 13 times the square of r equals 36. Divide the equation by 13. It implies that the square of r equals 36 divided by 13. Find the square root of the equation, and we have that r equals 6 times the square root of 13 all divided by 13 in units. For solution to question 2. From triangle EOA. Using Pythagoras theorem, the square of A, E equals the sum of the difference of the square of line A, O and the square of line EO. Substitute values, and we have that the square of A, E equals 16 divided by 13 after simplification. It implies that take the square root of the equation, and we have that line A, E equals the square root of 16 divided by 13, which equals 4 times the square root of 13 all divided by 13. Since line EO is a line bisector of line AB, thus line A, B equals the product of 2 and line A, E, which equals 8 times the square root of 13 all divided by 13. Also, from triangle COF. Use Pythagoras theorem. The square of CF equals the difference of the square of CO and the square of FO. Substitute values, and we have that square of CF equals the square of 3 minus 36 divided by 13, which equals to 81 divided by 13 after simplification. Take the square root of the equation, and we have that the length of line CF equals the product of 9 and the square root of 13 all divided by 13. But line FO is a line bisector of line CD. It implies that CD equals the product of 2 and CF, which equals to the product of 18 and the square root of 13 all divided by 13. Thus, area of ABC D equals the product of the sum of AB and C, D and half of EF. Substitute values, we obtain that the product of the sum of AB and C, D and half of E, F equals 12 square centimeters after simplification. Therefore, the required area ABCD equals 12 square centimeters.